The question is, find the maximum elongation of the spring. Initially, it is at natural length. Now, a constant force F is being applied on this block of mass M. This surface is smooth. Then you tell me at what is the maximum elongation in the spring. Did you solve it?
I'm solving it, sir. Sir, I'm actually struck, sir, on
You
this
see it.
point. Every time
What did I tell you here? Varun, are you ready?
W,
You see here. What did I tell you? Work done by external plus work done by non-conservative.
non-conservative plus work done by conservative.
Minus mechanical energy initial.
Initial.
So here,
Yes, sir.
smooth is there, it is 0, right?
Yes, sir.
But external work force is there, right here.
Yes, sir.
Suppose I am thinking the maximum extension is this one. Suppose x naught. Okay.
Okay.
At that point of time, what is the work done by external force? F into x naught, right?
Yes, sir.
That is equal to mechanical energy final is what at the maximum extension. What should be the velocity? Yesterday I taught you this one.
0.
0.
0.
So half into m into 0 square plus what is the gravitational potential energy? 0 only, na? Initial or final, both are things. Because I took the reference to be 0. If it is going upwards or downwards, then there might be change in the gravitational potential energy. So here, gravitational potential energy is 0 plus spring potential energy is how much finally?
K by 2 x max.
K by 2 x naught square.
Initially, it is at natural length. So
Yes, sir.
initial velocity.
Yes, sir.
Initially, it is at rest only. into m into 0 square kinetic energy plus potential energy gravitational 0 plus spring potential energy is how much?
0.
Got it?
0.
Got it?
Yes, sir.
F
Yes, sir.
x naught is equal to k by 2 x naught square, x naught cancel. So x naught is equal to 2f by k. That's it.
Sir, here I've got one doubt, sir.
Tell me.
Sir, you said it is like work done by conservative force. Where is that, sir?
Work done by conservative is converted into delta U, right? Minus delta U. That is sent to the right side. That is only we are writing the U final minus U in initial.
Yes, sir.
Conser-
That's what I wrote. Well, I wrote WC plus W external is equal to KF minus K, and I was thinking what to do. Like,
so then W conservative here, spring force energy you should to write. You need to write.
yes, sir.
Spring force energy is how much? If in that formula, if you substitute minus k by 2 of x final square, that is x naught square, minus x initial square, that is 0 square. So this minus k by 2 x square, if it goes to right side, is this or not?
Yes, sir.
Plus. So if you
Yes,
use
sir.
that formula also you'll get. But instead of writing conservative force work done, it's better you write a change in potential energy and take
Okay,
it to
sir.
the right side.
Okay, sir.
It's nothing, just it's a convention that I follow. That's it.
Okay, sir.
Then this is a very important question, 5-star question. In your exam, it might come also.
Yes, sir.
Yes, sir.
Basic concept of work per energy. So people will try to do a lot of things to this. Okay. Students will use their brain to derive a lot of answers. So now I'll ask you a question.
Okay.
Okay, sir.
Okay. There are two situations I'll give you here. So same block M. Okay. This is also K. This is also K. Now here I kept my hand and gently lowered it so that it comes to rest. Okay.
Okay.
Now, what
Yes,
is
sir.
the extension of the spring in this question? Now, in this situation, what I did, just I left that block.
Hmm.
There, I tried to, can you imagine the situation? One case, I am trying to lower the block slowly with my hand.
Okay.
And whenever it got to rest, just
Okay, sir.
stop it. It can stay on its own. Okay.
Okay.
The other situation, what I did, just I left the
Okay,
block.
sir.
What will happen? The block will come up and down, harmonic motion. It will execute or not. Varun,
Yes, sir.
Yes, sir. Yes, sir.
the situation, if you leave this block, second situation, what will happen? Just you abruptly leave. So the block will like this oscillate or not.
Yes, sir.
Yes, sir.
What is the find the maximum extension of the spring here? You try this question and tell me the answer. It's a very important question. 2 or 3 times this question is asked in different examinations. Engineering and medical, both of them. AIMS also.
So for the first one, I got root of 2 mgh by k.
Second one,
I don't know, sir. I'm doing it. Sir, I don't understand the difference between the first one and second one, sir.
okay. Varun, are you ready? Shall we solve it?
Sir. Yes, sir. First one.
First case, on this block after equilibrium, there will be an upward force which is kx due to spring force, kx naught, after displacement of x naught. So downward force of mg, right? If it has to be in equilibrium, kx naught is equal to mg, just force balancing. X naught is equal to mg by k. Okay.
Yes, sir.
But second case, you carefully see. That is a 5-star. Here initially, I am considering this to be potential energy is equal to 0 here, this level, initially. Initially,
Yes, sir.
it is a natural length. Okay. Now you see, there is no external force, 0. Work done by external force, 0. Plus, there is no non-conservative force, 0. That is equal to mechanical energy final minus mechanical energy initial. This implies mechanical energy final is equal to
Mechanical.
Inertial.
that is ki plus ui is equal to kf plus uf. Okay. So initial kinetic energy is how much? 0. If you just leaving like
Yes,
this.
Yes, sir.
Final kinetic energy is also 0 because maximum
0.
extension point. I'm assuming there's a maximum extension point. At that point, the final kinetic energy should also be 0 because after if it is not the maximum extension point, if it has a velocity, the block will still be lowered down, right? It will go further down.
yes, sir.
So its velocity
Yes, sir.
should become 0 at that maximum extension point, isn't it?
Okay.
Okay, sir.
You see here, like this, it has come here. If still it goes further down, that means here velocity is not 0, right?
Yes, sir.
If
Yes,
it is
sir.
going further down here, it cannot go beyond it. That means here velocity will become 0 and it will again turn upwards, right?
Yes, sir.
Initial kinetic energy is 0, final kinetic energy is 0. Plus initial potential energy is gravitational potential energy is 0, and spring potential energy is also 0, right? Natural length.
Yes, sir.
So
Yes, sir.
final potential energy gravitation is how much? It is lowered by x naught, x max I'm taking, okay?
Yes, sir.
Mg into
Yes, sir.
minus mg x max or not, going downwards with respect to reference line.
Good.
Do you know
Yes,
this or
sir.
not?
Yes, sir.
If
Yes,
reference
sir.
line is there, if you go down from the reference line, minus mgh. If you go above the reference line, plus mgh, right?
Yes,
Yes,
sir.
sir.
Here reference line below x max. So minus mg x max plus potential energy due to spring force is how much? Plus k by 2.
X max square.
It's over. So k by 2 x max square is equal to plus mg x max. X max cancel. So x maximum is equal to 2 mg by k, which is actually similar to our previous answer, like here 2f by k.
Okay.
Same concept
Okay,
application kind of thing. Okay. Here that external force
Yes,
is indeed mg here. That situation is like this. You see here. Block is there. External force is like this. Here, see the same situation, similar. Block is there. That external force is mg here. Okay.
Yes, sir.
Here 2 mg by k you got. Here mg 2f by k you got.
Yes, sir.
You understood this concept?
Yes, sir.
Actually, what will happen here? Carefully listen to the entire concept here. This is a very beautiful question. Examiner might ask you at any day. That kind of question it is. You're not trying to remember, right? Are you understanding the concept that I'm teaching?
Yes, sir.
Yes, sir.
What will happen? The block will slowly come. Initially, velocity is 0. Slowly, because mg force is there, this kx force is smaller force. K initial x is small, right? X is 0.
Yes, sir.
Yes, sir.
Mg force will bring the block downwards. So what will happen? Block will keep on accelerating. Block will keep on accelerating. So, but at one point, slowly kx will also increase or not, because x is increasing.
Yes, sir.
Initially, mg is greater than kx. So that is why block will keep on accelerating. At some point, mg will be equal to kx naught, right?
Yes, sir.
Yes,
At that point, force will become 0. Downward force is equal to upward force.
Yes, sir.
So by that time, the block might have got some velocity or not, because it is accelerating.
Yes, sir.
Due to that velocity,
Yes, sir.
the block will further go down. So at that
Okay.
time, kx is greater than mg or not,
Yes, sir.
because x is increased
Yes,
or
sir.
not.
Yes, sir.
Yes, sir.
So now what will happen? Kx is greater means upward force is greater than downward force.
Yes, sir.
So the block will slowly
Yes, sir.
decelerate, and the block will come to rest at a point where velocity is equal to 0. Then again the block will turn backwards,
0.
and it will accelerate till here. It will come again to v velocity here, and slowly it will decelerate again here. Again it will come to 0 here. You got it?
Yes, sir.
So like that, it will
Yes, sir.
oscillate like a spring, up and down, up and down. At the mean, this is the mean point, simple harmonic motion. This is the mean point where mg is equal to kx naught. That is, x naught is equal to mg by k. This is the extreme point where x max is equal to 2 mg by k. What will happen is, if this is the mean position, the block will oscillate up and down with this one value mg by k. If this value mg by k, total maximum extension is 2 mg by k, and the amplitude is mg by k, and this is the extreme positions,
Maybe.
and this is the mean position. Got it?
Yes, sir.
It's a
Yes,
beautiful
sir.
concept, right?
Yes, sir.
Yes, sir.
Have you ever solved this problem, this kind of problem? This is
No,
a
sir.
beautiful problem, because number of times
sir.
examiner will try to touch this question. I want you to carefully see this question. What actually happened in this question? Okay. Next concept is potential energy of. You understood how to apply the work energy theorem,
Yes,
Yes,
sir.
sir.
but still we will apply the same concept to previous year questions and also HC Verma questions. Same concept.
Okay, sir.
So whatever
Okay,
we
sir.
applied in these example problems.
Okay, sir.
Now potential energy of extended bodies, this is one thing. Suppose there is a particle here, okay, of mass m, which is at a height h. Here you consider potential energy to be 0. Now what is the potential energy of this particle?
Zero.
Huh? This particle is at a height.
MGH. MGH.
Pardon?
Um, MGH, sir.
Okay.
Potential energy.
But if I give you a say similar mass body, suppose
Okay.
this is like a rod here of length h. What is the potential energy of this rod?
M.
I think we'll have to integrate it, sir.
Okay.
Variable.
The answer will be, we can assume this extended body is a uniform extended body. We can assume this entire rod is at a height of its center of mass.
Okay.
So this rod is uniform rod. The center of mass will be at a height h by 2. The potential energy will be equal to mg into h by 2. Got it?
Oh, yes, sir.
For extended bodies. Even if you integrate, you will get h by 2 only.
Okay.
If you take dm and integrate, you will get h by 2 only. Okay.
Okay, sir.
So now we'll solve a question. This is a question asked in one of your previous year questions, maybe.
Okay.
There is a chain.
Yesterday you told this, no, sir?
There's a chain. This is L by N part is here. Okay.
Oh, yeah.
Okay.
Yes,
L by N
sir.
part is here. Standing. This is L minus L by N. Okay.
Okay.
Here L by N part is standing here like this. Total chain length is L and mass is M. Okay. Now the question is, what is the work done to keep this chain, this hanging part on the table? Work done
Okay.
to keep the hanging part of the chain on the table. Okay. Haribol, I mean class. Is there anything important? Tell me, is it important? So within another 10 minutes. So here you see carefully. Work done by, that means what is the work done to keep the hanging part of the chain on the table? Means someone should come and keep this hanging part of the chain on the table, right?
Yes, sir.
That
Yes,
is
sir.
external work done, right? Work done by external force.
Yes.
I told you, but work done by non-conservative is equal to mechanical energy final minus mechanical energy initial, right? Concept.
Yes,
Yes,
sir.
sir.
Here there is no friction and viscosity, so this will become 0.
Yes, sir.
K final
sir.
plus U final minus K initial plus U initial. Here in this situation, I told you a special case wherein K final is also 0, K initial also 0. Just keeping the chain on the table. That means you are not giving any kinetic energy to it, right?
Yes, sir.
So initial kinetic energy is also 0,
Yes,
final
sir.
kinetic energy is also 0. This special formula I told you, work done by external is equal to, in these special situations, this is a formula that will be used. That is the main derivation from this formula only, main formula.
Okay.
Yesterday I told you, right, this formula?
Yes, sir.
Examiners are, I don't know, sometimes examiners are interested in asking this kind of questions. Where initial kinetic energy is not mentioned, final kinetic energy is not mentioned. That means initial final kinetic energy is a 0 here. So work done by external is equal to U final minus U initial. So what should I do here?
Initial.
So let me consider here potential energy here to be, for suppose if I consider potential energy here, anything you can take. You can take it to be here or you can take it to be here. Potential energy is equal to 0, reference line, okay?
Yes, sir.
You can take this also, but you will get the same answer.
Okay.
You see here. If I take potential energy 0 here, what will be the potential energy of this chain here? L by N chain. What is the mass of that
L
chain?
by M.
M by N. M by N into G into L by 2N, right? L by 2N because mgh by 2.
Okay.
mgh by 2,
Why 2, sir?
mgh by 2.
Okay.
There, potential energy of an extended body. This is not a particle. This is a extended body.
Okay. Okay.
It will be at the center of mass.
Okay, sir.
Okay.
It will be at the center of mass. So center of mass will be at here. L by 2m, half of this distance. Suppose this is 5 meters. Center of mass will be at 2.5 meters if it is uniform chain.
Okay.
So the answer will be m. M is how much? This part of the chain. M by n. G into L by 2n. This is the potential energy, right?
Yes, sir.
Initial potential
Yes, sir.
energy. Initial potential energy is how much? Potential energy initial is equal to first m by n, G into L by
About
2n
2N.
plus that remaining part of the chain.
Okay.
How
That
much
is
is the
L minus L by
So m by,
L minus L by.
is it m by n? Sorry, for m for L length this is m mass. Uh, for L by n length, what is the mass? The answer will be
Mn.
no, sorry, x. X into L is equal to m into L by n. L cancel, m by n only. Okay. M by n into G into L by 2n plus remaining part mass is how much? M minus M by L, M by n. Okay.
Okay.
Yes, sir.
M minus M by n into G into how much is the distance? L by n distance or not? Because this entire chain is at one height only, na? This is completely how much
Okay.
distance? L by n distance or not? Entire chain is at horizontal distance, horizontally.
Yes. Yes, sir.
Because this chain is vertical is existing. This chain is horizontal only. So entire chain is at the same distance. So that is the potential energy will be center of mass of this will be like this. It is at a high distance of L by n or not?
Yes, sir.
Yes, sir.
So the answer will be initial potential energy is m by n G L by 2n plus m minus m by n G L by n. Okay.
Yes, sir.
Final potential energy is how much? Finally, you are keeping the chain on the entire chain on the table. So that will become how much? M into G into L by n, right?
Yes, sir.
Yes, sir.
Did you understand?
Yes, sir.
So
Yes, sir.
potential energy final minus potential energy initial, that is mg into L by N minus mg m by
L
N
by 2n, sir.
dl by 2n plus mgl by N minus m by N gl by N. So this will get cancelled.
N.
So what will happen here? So minus of minus, this will become plus, right? Let me check.
Yes, sir.
This will become plus. So the answer will be how much? This will become minus. Sorry. mgl by N minus mgl by 2n. This will become minus, and this will become minus and plus.
Okay.
This will
Okay,
become
sir.
minus, and this get cancelled. So the answer will be how much? mgl by N square minus mgl by 2n square, that is equal to mgl by 2n square. Got it?
Yes, sir.
Yes, sir.
You can solve it again if you can simply. So there's another way. Actually this has become bit more bigger calculation. Shall I try to do it in the next class? Wait, I'll send you another link.
Okay.
Yes, sir.